Okay, in this video, we're going to complete our discussion on the scoring process in the 3v3 mode and the respawning of players in between rounds. So we thought we'd go over the high level concepts first and then jump in and look deeper into the blueprint code. So first, just to compare and contrast a little bit of the match logic between elimination and a 3v3 round. So in the upper right, the Lyra game mode and Lyra game state are responsible for the actual game mechanics and how a game functions. A game mode being the primary asset that has control over a game, defines the rules, and only exists on the server. Its sister class, the game state, exists on the server and the client, and what allows the clients to sort of know the overall game state at any point in time. In Lyra, we add the 3v3 scoring method to the game state. That 3v3 scoring method inherits from the game scoring base class. So the scoring is added to the game state, which exists both on the client and the server. Now, in a normal elimination match, there are three primary phases: the match warm up, where players move around and other players are joining before the match actually starts. Then there's the physical start of the match. And in standard elimination, you follow the dotted line and you basically wait for the victory conditions to occur, either that being the timer ran out and one team has more kills than the other team, or someone reaches the kill limit and their team is deemed victorious and the match ends. What triggers those match start and match ends is the Lyra game phase subsystem, which has a start phase node, which you can see in the screen here, and it pushes a game through the various phases as the logic dictates when a game should move from one phase to the next. So in the standard elimination, what happens is you move out of the warm-up phase into the active phase, and then upon victory, you move into the post-active phase. And as soon as that happens, all the variables are wiped out, and a match is reset back to the beginning. So in a standard elimination between match start and match end, there's really nothing other than counting up kills until such a time as the game logic triggers the Lyra game phase subsystem to switch to the post-game mode. That won't work for us because we have to reset a round in between those two bookends. And so we have a concept of starting a round, which there could be 2 or 3 rounds, depending on whether or not there's a decisive win by one team in both first 2 rounds, or it takes all 3 rounds to determine the best of 3. And then at the victory event, we have to make a choice. We have to make a choice whether we're going to reset the round and reset the players back to the start position and start again, or exit the match like an elimination and indicate that we're done with this overall match. And so the victory event becomes a decision point for us in which we have to decide what and how to progress the game. If you dig deeper into how scoring is occurring, the triggering event for scoring a kill is the on elimination scored. So that function gets triggered whenever a player dies. It doesn't matter which team the player dies for. Someone dies, that event gets triggered. We then have to override the standard elimination logic. So the standard elimination logic says, okay, count up the team that ended up doing the killing, the non-dead team, determine whether the match is over, and then just simply end the match by phasing to the post-game phase. So standard is a very simple path. Someone dies, we add the count, we check the count. If the count is at the scoring total, we simply end the match and we're done. In our work, we need to take another condition check, right? So the first happens is someone dies. We determine, is the round over? If the round is not over, we just simply keep playing. If the round is over, we then have to check whether this round determined whether the match was over or not. So if this was the very first round, this would never occur. But if it was the second round, it might actually trigger the match over, in which case we continue down the normal branching path and end our match. However, if no winner of the match is determined by this round, we then have to reset the round and get all the players back into their starting positions, which is where most of our new code can be found. And then we keep playing until, again, we get another round over event where we run through this check logic one more time. So there's just a bit of a difference between how elimination standard logic flows on the dotted line and how our logic flows through the more solid lines. So how do we inject this logic into the Lyra game? So as we talked about in the other video, there's 2 points to really consider. The first is that the ability set that you grant each and every player has to include our respawn listener event. So this is a gameplay ability that each character will get. Because there's no input tag, it is not triggered by input. It's triggered via the game logic. But it sits and listens on all players for the appropriate trigger points, and then it does what it needs to do for that player. In the gameplay experience class, in the components list, we add the 3v3 scoring component to the Lyra game state. So this is where we add our respawn listener and our scoring class into the Lyra game framework. All right, let's look at that respawn listener at a macro level. So here's a screenshot of our respawn listener, and we'll go in a few minutes to the editor and we'll zoom in and take a closer look at it. But I thought it's important to look at it from a high level first. Starting on the far right, where the arrows are indicating, when the respawn listener is instantiated in game, it is automatically activated. So you see the on spawn activation policy, which says that as soon as this is activated in game, I want this respawn listener to fire right away. The second thing is I do not want the client to be able to cancel it. So the check mark is removed for server respects remote ability from a client. So the client can't cancel this. We have a net security policy that says it's only initiated on the server so that it'll throw a warning message if we attempt to initiate this from the client. And then it has 2 gameplay tags. One is the survives death tag, and one is the auto respawn tag. The survive death tag indicates that when we reset a player, or respawn a player in a round, this ability is not removed. The other abilities would be removed. You'll see a place in the logic where we remove the abilities on death. This one does not get removed because of this tag. In the middle, you see we've broken the core blueprint logic up into 3 chunks. There's a chunk of code that executes upon startup. This basically sets up the gameplay ability, gets the listeners listening for the appropriate events, and then basically sits and waits for something to trigger. We have our main logic where we coded in red the main death logic and the main respawn logic. So in red, the death logic, and green, the respawn logic. That's the main 2 events that this respawn listener are going to respond to. And then we have a few cleanup activities whenever the ability is removed or ended. So we'll spend a little more time digging into the respawn, but it's good to kind of see that high-level macro view as we then jump into the code and start looking at it in a bit more depth. Similarly, for the scoring logic, there's not really any real properties on the right-hand side that are relevant to the way the scoring logic works. We have our standard startup activities where we push from the warm-up into the main phase with the Lyra phase subsystem. And then we basically sit and wait to die. When death gets triggered, we start processing our logic. The main loop, so at the bottom, the main loop in the yellow block is when the timer runs out and we force a tie. So in a case of 3v3, if the timer does run out, that means there's at least one player on each opposing team still alive, so therefore it's a tie. And then the bottom section is our reset round logic, which is our macro logic we call when we reset the round. For organizational purposes and being able to track through it, the main logic sits in a series of functions. First, the on elimination scored, which we just talked about from the parent class. So you can tell that a function is being overridden from the parent class by the look of the function icon in front of it. So if you notice, this function icon has a arrow and it's a little more grayed out. So that means that it is an override function from the parent class. So that on elimination scored gets triggered by the underlying logic. And then we have 4 primary logical blocks. One, to process the victory event. This is where we determine whether or not a round is over or the match is over. Then we have a process match event. And then we have 2 handles. One to handle the round over, which displays the appropriate, your team is either won or lost. And then one handles the match over, which says victory or defeat. They're very similar in that they just push the screen, your team has won, your team has lost, or you're victorious or you're defeated, to the player UI. And then the rest are sort of functions that are called throughout that. So that's the main overflow of how the scoring looks. There's one last thing to talk about before we jump in and take a look at it in action. And that is, in the Lyra code, there is a special gameplay ability for reset. So this is all coded in C++. If you don't look into the C++ code, you won't fully understand that this is happening behind the scenes. But there's an ability that's sitting and listening for a specific gameplay event, and that is request reset. So when you send the gameplay event to an actor, and that gameplay event happens to be the gameplay event request reset, then this piece of code that is underlying in the C++ will get triggered, and it will perform all the actions necessary to strip a player of any inventory, reset them to a spawn point, all of the sort of restart activities that are necessary. Now, it does rely on the player being active. What we found is that if a player is in a dead state or in a non-activated state, that this can be a bit buggy. But we basically wake up all the actors again and then fire this event to reset them all back to the starting point. All right, so with that overview, let's next jump into a gameplay so you can see it in gameplay mode. And then we'll come around and we'll look closer at these 2 classes in the editor. All right, let's start by launching a few matches and try to create each of the conditions we need to debug the code. So you can see at the top of the screen, they have killed 2 of our players. The blue team is winning. I am stuck in eliminated mode. And your team lost the round. So the round over is triggered. We're reset back to our starting point. And we're going to make another attempt at this, which, as usual, I am the problem child. largely because I lag a lot when I'm on the 4K monitor. And now we're defeated because we lost 2 matches. At this point, it's going to re-show the loading screen and start the next complete game. So now we're in a brand new game. I will attempt to do better. Usual, I get nowhere. Now I'm stuck. No. And we finally won a round. Yeah, there's only one of us alive on each side. Does not look good for me. So let's look at the respawn listener first, and then we'll look at the scoring class and look at and see how that component interacts with the respawn listener. But the first thing I think to understand is what's happening while a player is dead. So as we open this up, we don't need the details. We talked about those earlier. So the first thing the respawn listener does is as soon as the ability is added, and if you remember, it's added upon initialization or spawn, we go ahead and register the spectator prompt with the UI extension subsystem. So this basically puts the spectator window in the UI It starts off hidden, but it basically establishes that right up front as the very first thing it does. Then one of two events are going to trigger, either the activate ability or on pawn avatar set. And there's just different conditions when the on pawn avatar set gets triggered versus the ability activate gets triggered, but both of them basically arrive at the exact same point. Lyra does a logging of that in this log event, which I've replicated over to the scoring control. So I've used this log event code because I think it's a clean way to deal with some sort of print string type stuff. It performs a sequence, so it runs these two in parallel, so they do not need to run sequentially. This one can start executing, then this one can start executing as well. The first thing that the respawn listener does is, and you'll see this logic quite common, it checks if it's already listening. If it's not listening, it then starts listening and then tells the system it's listening. So in cases where things might fire twice, you only want one listener up and running. This is a very common block of code where you'll see something check up front, and then upon performing it once, we'll basically set a Boolean flag to prevent it from happening again. So this sets up and listens for a reset. That event occurs from that C++ code we showed earlier. Once a reset is complete, it then fires this message, which can be picked up here in the code. And then basically this will follow this logic through, checking to make sure that the reset event is actually for this particular player. If the player doesn't match, if it's a reset event for another player, it basically just fails out quietly there. And then continues to basically stop listening for any death events, respawn the player. So this is if the system gives me a reset, I'm going to perform that chain of events. Same thing as if the avatar hits the end play event, then we'll also trigger that reset logic. In parallel to that, we determine if, for whatever reason, we happen to be dying at this very moment. This could be a case where we just got shot in the warm-up phase and we're in the middle of dying and the match is about to start. Then we basically will just immediately launch into the death started logic. Otherwise, we will bind the death listener. And so this binds and listens for the death event. So this is binding to the health component. Here, let's go in that. So this is standard copied over from the other one. So whenever we're binding a new death listener, we clear an old death listener. We get the event here and bind the actor event. We find the health component. We make sure it's valid. And then we bind ourselves to this on death started. So this binds to the on death started event, which if I expand is right here. So we create this custom event called on death started. In this routine, we bind it to the health component. So we take this health component, which is the target, and we bind its signature to this on death starting activity. So this is now listening for death of a player. That's all the startup. So we are listening for a reset message, and we're listening for a death event to occur. Then we basically sit and wait for that period, for either of those two conditions to occur. The case where the on death event occurs, which is being sent from the health component, we clear our death listener. There's no need to listen while we're dead. It's not going to happen again. We save off our controller. And now we wait for the request round reset event. So now that I'm dead, I'm hooking in and listening for yet another event. This particular event is the request for the round to be reset. That's the only condition that will cause a player to respawn, is if our scoring logic triggers this message, which you will see later. We then fire up the spectating widget. So we pass in the respawn delay duration, which we're not actually using anymore, but this basically says how many seconds are left in the match. It does trigger that little circle that goes around slowly around the X. And we send that through with the ability to respawn duration message. So we broadcast that message to the widget. And that's it. We're dead and we're lying on the ground with the eliminated spectate window in the center of the screen. If and when we do receive this message, we will trigger a respawn player, which is this logic here. So the respawn logic will trigger. We'll log that event. Here's where we clear all of the abilities except for the abilities that are tagged to not end. Right? So the end abilities, let's just go into that one, says find any ability that has a type of death and basically end all of those abilities. So this is simply clearing off all of the end abilities that are associated with, sorry, any of the death abilities that are associated with this player because we're about to be respawned. We then have, this is from the Lyra code, why it's not moving. Basically, they do a little delay between, just to make sure things have cleared out and reset. We found we had to increase it to 0.2 from 0.1. But nonetheless, you do a delay. You get your game mode, and then you tell the game mode that I want to restart this particular controller. So we do a restart, and we ask it to do a reset as well. So that reinitializes the player into the world. And then we tell the rest of the systems. So we broadcast that we have completed our respawn. So this broadcasts both to the server and to all other clients that we're back up and running. Then we determine whether we can execute our cosmetic events, which is the reassembly of the character from pieces. And we broadcast that we are complete, and the spectator window is listening to this. So at this point, when we broadcast this message, the spectator widget is listening for this message and it will hide itself. So once this message is received, one of the beautiful things of a sort of broadcast-based system is you don't care who's listening. You just simply broadcast that this has occurred. Any and all classes, widgets, etc., that are listening will pick that up and do whatever they need to do. So in our case, the spectator widget is listening, and when it receives this, it goes and hides itself. So as far as main functions that are, most of these are identical to the elimination. These are all the same. These are the ones that we just talked through here. I just flipped these two because it's more logical sequence to end the ability first and then remove it. But when we end the ability, we clear the death listener, and that's it. When we remove the ability, we clear the death listener and we remove the spectator window because we're not going to need it anymore. So there's just a slight variation between ending and removing. And the rest of these are all standard from the Lyra project. So that's it. That's the actual, I keep forgetting, respawn listener. So hopefully that makes sense. Now let's take a look at the scoring class. Oh, before we do that, so we copied the respawn widget from Elimination, and we just made some very simple changes in here, so it's probably worth pulling that up. No changes in the designer. We left that identical. In the update respawner text, this function here, which basically is doing all the math for counting down to the 5-second respawn in elimination. We still do the circle around the edge of the UI. However, we don't update the center countdown, which would go from 5, 4, 3, 2, 1. Instead, we're placing a big X in the middle of that because there's no need to count that down. This is going to be basically an X. And then we change this text, which I think was had something different. Anyway, we changed it to eliminated and then added this spectate button, which we have not yet coded, but that will allow you to move into spectating mode, which we'll probably do in our next video. And then on the graph, we somewhere are listening. Yeah, so we're now listening for that completed of a respawn message. When we do, we force the on timer finish. Now there was some other logic back here that we trimmed off we don't need. So if you see logic in yours beyond this on timer finish, you don't need it. And then what on timer finish does is basically just hides the window and clears the timer because you don't need to be ticking down anymore since the window is no longer visible. So those routines were slightly modified from the elimination versions to make our spectator prompt do what we want it to do. Then over to scoring. So in scoring, let's just do the same sort of walkthrough. So scoring launches upon begin play of this component. It makes sure that we're on the server. It waits for the experience to be ready. If all that is true, we then move our game out of the phase warm-up stage. We move into the phase warm-up stage. The code will take us out of phase warm-up. When that occurs, this phase ending, the warm-up phase ends, will trigger the game started routine. So the scoring puts you in warm-up. The code behind the scenes in the C++ eventually moves you out of warm-up, which triggers this bound event here and starts game started. As we said in our other video, these are fixed. So we've trimmed that logic out so we don't need that logic. We start the countdown. So we bind a looping event called countdown, which is here on the graph, called countdown. And we count down looping every 1 second. Store that into a handle. And basically just, what's going on? We basically just now wait, right? So the scoring is up and running. The countdown timer is ticking every 1 second. It's replicating that new time from the server to the clients so they see it. If we ever get to 0, that's when we trigger our tie. And the way we trigger a tie is we process the victory event in which team 0 is the winner. Now there's a little bit of weirdness in the scoring logic from Lyra. Your team numbers are 1 and 2. Therefore, you can pass 0 in here and have that be a draw. However, there'll be points in the code where you'll see 0 and 1 representing the teams. And therefore, there's some back and forth flipping between team 1 and 2 and team 0 and 1. They can be a little confusing, but know that your actual team IDs are 1 and 2. Therefore, 0 is a test for a draw. All right, so that means we would process a draw. And now let's look at the main loop. So if timer were to run out, we would process the draw. However, every time an elimination is scored, and here you see the getting team score for team 1 or team 2, we call this routine to see, okay, someone just scored, but we don't know who. So we basically determine, is team 1 victorious? or team 2 victorious. And so if we're victorious, we will process a victory event and hand it the team that was victorious. So we loop through this twice. The first time, if team 1 is victorious, we call this. If the second time through team 2 is victorious, we call this. If neither of them are victorious, we just exit out. So what could possibly happen? Let's go to the victory event. In the victory event, we determined if it was time 0. If it was team 0, that was a tie. So we just handle the round over in a tie. If somebody won, either team 1 or team 2, we'll do a match process. So we're going to process to see if the match is over. And that'll either come back that the match is over or the match is not over. If the match is truly over, we're going to say match over, and we're going to finish. This ends the entire process. If the match was not over, which means the round was over, somebody won, but the match is not over, then we're going to handle our round over. And so these two, the handling of the match and the round, are determined based on the output of the processing the match, whether the match was victorious or not. So let's look at the round over first, and then we'll come back and look at the match over. So in the case that we're round over, we will trigger the activate user facing queue, which is this function right here. And that's what fires up the round over message. We pass the team ID into that, which if you just dig deeper into that code, you'll see how that works. And then we do a request to reset the round. Now, if you're copied from Lyra, the standard logic would be that we move into the post-game phase. You don't want to do this on a round because that will reset all of your variables and set you right back to the beginning of a new match. So instead, when a round is over, we simply request the reset, and then we have to handle all of the resetting of the players in that logic. So we'll come back and dig into, well, let's do that now. So in the case of the round's over, we're going to reset the round. We pause for 5 seconds because the screen is up and showing that your team is either won or lost. So we give the player 5 seconds to read the message that the team won or lost. We reset our counter back to the full 5 minutes. We remove the won or lost window from the screen. We reset all of our team tags. And I'm going to come back and walk into this. This is the difference where we have to reset the eliminations. We then tell all the dead people to get up. So we request the round reset, which if you remember, the respawn listener is sitting and actively listening for this particular event. So we send that event out so that those people will get up. We give them 2 seconds to get back up off the ground. And then we trigger the reset all players. So this triggers move everybody back to the starting point, take away anything they might have, reset their bullets. All of those things are performed in this function. So the other important function is this reset team tags, which we have here in our folder structure somewhere. That was hard to see. Reset team tags right there. And what we're doing in that function is we're looping through both teams. So very similar to the way the victory conditions were checked, we're going to do it for both teams. We're storing it in a local variable just so that we don't have lines running all over the screen. We grab the team subsystem. We determine how many eliminations does that team have. And then we remove that. So we set it back to 0. So this forces it to be 0, right? By fetching how many they have and then removing the exact same amount from that team, you basically say, okay, go back to 0. So that sets those tag stack counts to 0. So we now have 0 eliminations. We technically don't have to do this, but we reset the assists back to 0. And we reset the player deaths back to 0. So all 3 of those are set back to 0. All right, so let's dig into this, right? How do we determine whether or not we should be end of round or end of match, right? So we know that a team has won, and we now need to know what to do about the fact that they've won. So let's go into process match. All right, the very first thing you need to do is we increase the number of victories that team has. So this is a brand new tag that we added to the shooter game score tree called victory. So victory doesn't exist in yours. You'll have to add that. Well, what we're doing is every time a team wins, we're incrementing this victory tag on the Lyra team subsystem. Now we're just logging out for debugging purposes which team it was. Then we get the total number of tags. So this added 1. This could be 1 or 2 or 3 or whatever the number might be. We check if it's greater than or equal to our target match score, which is set to 2 right now, since we're doing best of 3. If that is true, we're going to pass back victory. If it is false, we're going to go back for another round. So the only thing we're doing here is tracking the number of victories each team has and determining whether or not we should trigger a victory for the match or the round. So that's these 2 here. I think that is everything. So I'll just do a quick walk through these. Begin play, startup, those are all startup activities. I don't think force game over is ever used. It came over from the other scoring class. This is our timer event that's ticking down our countdown. This is the one we wrote to reset the round and broadcast to the players to get up. Get team score simply pulls the Lyra team subsystem and gets the actual score. On elimination, we talked through victory, process the match, handle the round over, the match over, reset the team tags. We talked through the set damage enable basically just assigns gameplay effects to players. I'm not even sure if that's used. Probably is. The activate and clear user facing is what throws your team has won or lost onto the screen. Here, the on rep. These are the replicated variables that are set on the server and then sent to the client. So in this case, whenever the client gets a rep target, this triggers on the client. We count the player. Same with the countdown. This triggers on the client, and it basically updates the client's countdown. And then our 2 logging events that are defined down here. So hopefully we covered everything. If I missed something, we can address it in the comments. Oh, I guess the only other thing to talk about is on the UI, not that UI. In scoring, when you activate a user-facing queue, you're basically adding a gameplay queue to the actor. And that gameplay queue, which is whatever is passed into this routine. So the round over passes round over user message, and the match over passes match decided. So the match decided is base standard Lyra. We added the user message round over as a new gameplay queue. And those are being listened to. I'll just show you the round over one, which we copied. So if we go to the gameplay queue, this gameplay queue right here, which was a copy from the match decided, and the widget are both copies from the match decided. So the queue is listening for the round over gameplay queue. When it's received, it will throw the round over message window, puts that on screen. When the round over message is put on screen, this particular window, the only thing you have to do in this logic is the information comes through from the queue. The ability level is used for the team ID, so team 1 or team 2. We basically find out what team we are on. So our team, we might be team 1, the winning team might be team 2, or the winning team might be a draw. Right. So in this UI, if the time runs out and it's a draw, we set the text here. If the winning team and our team are equal, we say we won. If the winning team and our team are not equal, we say we lost. Those are the only 3 things you have to change in the round over. The rest of this is all standard, and it basically triggers basically all of that. And then here's where it's listening for the reset event. And when you do reset your players, then this removes from the parent. All right, so that sums up the scoring and respawning logic. I think what we'll move to next is we'll start to look at the spectating, so that you don't have to just sit and stare at the ground while you're dead, which I do frequently. And from there, we'll move on to sort of creating the characters that you can play. So thanks for watching. Leave a comment or a like, and we'll see you in the next video.